Alrighty, hi there, and welcome to part 2 of continuity. In this video, we're going to look at the numbers or values for which a function is discontinuous. So, functions are going to be discontinuous at points that involve the following: a hole in the graph. So, if there's a hole in the graph at a point, it's discontinuous. It's discontinuous there. Vertical asymptotes, which we've talked a lot about throughout the year, especially with the graphs of tangent, cotangent, secant, and cosecant. And any gaps in y coordinates. In other words, the left-hand limit is not going to equal the same value as the right-hand limit. So under these conditions, if you were to trace your function, you'd have to lift your pen or pencil up off the paper at some point if any one of these three conditions are met. So example 2, we're going to identify all discontinuities for the following problems. So we're going to start with f of x is x squared minus 2x minus 15 over x minus 5. And we can't have a denominator equal to 0. In this case, I believe there is a hole in the graph there because x minus 5 is a factor of our numerator, so we can remove it, removable discontinuities. But x minus 5, if that equals 0, we get x equals 5. So at x equals 5, there is discontinuity in this graph. We could not graph this function without having to lift our pen or pencil up off the paper at the x value of 5. So the function is discontinuous there at x equals 5. All right, part B, we have x squared minus 6x over x minus 6. Again, I believe we have a hole in the graph here where at the value of x equals 6. So once again, we have a function where we have a denominator that could equal 0. That's pretty much automatically a discontinuous function. So function is discontinuous at x equals 6. I believe there's, again, a hole in the graph there because x minus 6 is one of the factors if you factor the numerator. All right, part C, we have an example of a piecewise function. So we have the line x plus 1 for x values less than 2, and we have negative x for x values greater than or equal to 2. Well, if we take a look at x equals 2, there we have a left-hand limit of 3, and we have a right-hand limit of negative 2. So the left and right-hand limits don't equal the same number. There's a gap in the graph at x equals 2. So it's discontinuous at x equals 2. And everywhere else it's okay except this one particular value. All right, finally, part D, we have square root of x for x bigger than or greater than or equal to 0 but less than 4. So the graph in blue. And we have 2x for x is greater than or equal to 4. So for this function, this piecewise function, notice again we have a gap in the graph at x equals 4. So here it's continuous for all these values here from 0 and above, except at x equals 4 we have a gap. All right, part E, we have a 3-part piecewise function, or a 3-piece function. So in part E we have x plus 1 when x is less than 2. We have 3, the constant 3, when x is between 2 and 4. And then we have the graph of x squared minus 11 when x is greater than or equal to 4. Now, in the other couple past examples, it was where one piece, where it was broken up. So in the last couple problems, it might have been at x equals 2. However, as we can see here, that it is defined at x equals 2, and the left and right hand limits are the same value. They're both equal to 3, which is also the value of the function at that point. So you can't just look at what the endpoints or the extremes are for the intervals here, but look at the graph itself and make sure that the left hand and right hand limits are equal, and they're equal to the value of the function at that point. However, at x equals 4, we have yet another gap in our graph, so once again, this function is discontinuous at x equals 4. All right, finally part F, we have sine of x when x is less than 0, and we have x cubed when x is greater than 0. Everything's well and fine. The left-hand limit as x approaches 0 is 0. The right-hand limit as x approaches 0 is 0. However, the function's not defined at x equals 0. So we unfortunately, even though it looks like it's continuous, there actually is a hole in the graph there because the function's not defined at x equals 0. So that's where this piecewise function is discontinuous. Alright, that about does it for this video, and I'll see you next time.